AP Calculus BC, Unit 9, Day 1, Office Hours. This is a book assignment. These are the even answers. You should check your odds in the back of the book. So pause the video if you need to check these evens. On 30 to 40, you're stating whether it converges or diverges and naming the test. And then, of course, showing the work that goes with that test. So let's see how this works. Let's get the hang of this before we start adding some more tests. There's going to be a bunch of different tests. Some work for all series, some work for groups of series, some work for very specific series. So these say find the radius of convergence. Well, you're pretty much trying to find the interval of convergence. You're kind of being left off. You don't have to worry about the endpoints to find the radius. So number 7 in closed form was this series, which, by the way, is a geometric series. We could, you could try the nth term test, but that's not going to help you find the radius of convergence. But maybe I'll just go and start writing the nth term test. And I want you to write the name down. And the nth term test says take the limit as n goes to infinity of the nth term. And this one blows up and goes to infinity. So we would think that this actually does not converge, it diverges. Okay. Well, again, it depends on the value of x. Because if x is a fraction, then it would actually go to 0. So we don't use nth term tests on power series. I keep making that mistake. So we definitely want to go straight to the ratio test every time for power series. This power series has x's in it. And the directions do say power series. So we're going to do the ratio test, which says take the limit as n goes to infinity of the absolute value. And I'll just write it down here once. This is what it is, and you want it to be less than 1. So that's a ratio test in general. So let's do the work here for it. Ratio test. Limit as n goes to infinity of the absolute value. Now the n plus 1 term divided by the previous term, the nth term. Now we can often use algebra to simplify it. So that would just give you x. Absolute values are still there, rules of exponents, and it needs to be less than 1. So now we have this, and we want to solve this. Okay, I guess I should have put one more step. This equals the absolute value of x, which needs to be 1. So if we take the limit, it's just x. N doesn't even matter anymore on this one. So if you were to solve it, this is the interval you get. Now, generally, you have to test the endpoints. But if all you're looking for is the radius equals 1. Radius is, by the way, you're going to see the radius right here. Is if x doesn't have anything in front of it anymore, then that's your radius. If something's being added or subtracted to x, that doesn't affect the radius. But anything multiplying or dividing x, if you move it over here, then that's your radius right here. Okay? So the radius of convergence is 1. Okay, 10. So nth term test is more from number series. So we're going to take the limit as n goes to infinity of the absolute values of the n plus 1 term. So 3x minus 2 to the n plus 1 over n plus 1. That's the n plus 1 term. And then we divide by the nth term, which is exactly what you see there, or multiply by its reciprocal, which you're going to want to do eventually. So you might as well just set it up like that right away. So that's the setup. Now we should simplify it. Any way we can. So rules of exponents say we're going to have that to the first power. These can't be simplified. So you're going to have n over n plus 1 times 3 to the 3x minus 2. So that's what we get. Now, if you plug infinity in, you get infinity over infinity, but these are dumb terms. This is going to go to 1. So now what we have is absolute values are still there, limits gone, and this needs to be less than 1. Okay? So there's different ways we could do this. We could go ahead and solve this like that. And that's not the radius of convergence. Okay, I'll show you another way that we could do it. We could go and we could go ahead and kind of work towards finding the interval of convergence. And by the way, yeah. So this is our interval of convergence. And it's from here to here, it's 2/3, right? So the radius is 1/3. It's half the distance, right? Now, alternatively, what you could have done is got rid of that 3, because that's preventing that from being the radius of convergence. You could divide both sides by 3, still have the absolute values. If you do that, this is your radius. And yeah, you got to divide this one by 3 too. So this is the center right here. The center is positive 2/3, and the radius is 1/3. And you could use that ruler postulate that we used in Calc AB from geometry. And you get the same answer, but here's the radius, right? Here's the center. So you can see that stuff if you get rid of whatever's in front of the x in the middle of your work. So we could have just stopped there and answered questions about center and radius. Okay. So 11. So we're going to write the problem down. And then we're going to set up the ratio test, which we should write. And we're going to use it. I forgot to write it last time. I'll write it now. I want you guys to get in the habit of writing these tests. So this is based off the ratio test. It's the limit as n goes to infinity of the absolute values of n plus 1 in parentheses, x plus 3 to the n plus 1, 5 to the n plus 1, divided by the previous term, the nth term, or multiplied by its reciprocal. Now, the first thing I would do is just try and simplify anything you can in here. Don't even take the limit yet. Just rules of exponents and things like that. So rules of exponents often come in. So we got that. Rules of exponents here, we got that. So what we have now is n plus 1 over n, which I think are easier to think about when you put them above and below each other. And then x plus 3 over 5. So I haven't done any limit stuff yet. I just simplified it. Now, this can go to infinity over infinity, right? And that's just going to be 1. I'm letting you be lazy with that right now. So what we get is we get x plus 3 over 5 in absolute values, and it needs to be less than 1. Now, if you want the radius, my advice, so there's 2 ways we could do it. We could go ahead and start solving it, just get rid of the absolute values, or you can multiply both sides by 5, and there's your radius. And there's your center. Your center is at x equals -3. And then we could just stop if that's all they were asking us for, which is all they were asking us for. Otherwise, you could do more work to get the interval of convergence. But it's not necessary to do all this work. So, I mean, that's the interval of convergence. The distance between these is 10. That's like the diameter of convergence. So the radius of convergence is half of that. It's 5. But you could also get that answer a little quicker without having gone through all that work. Now, if you got to find the interval of convergence, then you could do it either way. I mean, you could do it this way too, which I still think is possibly nicer. And you get the same answer, right, for the interval of convergence. But okay, so that's 11. 14. Now, we're definitely, the first one was a power series based off the geometric series that we were studying last unit, but all these other ones are totally new things. This one has a factorial in it. Should be good at simplifying factorials. So ratio test, limit as n goes to infinity of absolute values. Now be careful here. You got to plug in an n plus 1 into here. So you get 2n plus 3 because the n plus 1 gets multiplied by the 2. And people totally put 2n plus 2 all the time. 2n plus 3. And then n plus 1 has to be in parentheses. Factorial on the bottom. Oh, and then you multiply or you divide by the previous term, multiply by its reciprocal. Okay, so the first thing I would do is I would just simplify things. So you got rules of exponents, right? This is going to leave you with an x squared. This n plus 1 factorial, same thing as n plus 1 times n factorial. So the n factorials cancel, and so you just have an n plus 1, no more factorial on the bottom. Right? Now, as you take n to infinity, x is just some number. So it's not infinity over infinity. It's some number squared over infinity. It is going to 0, no matter what x is, which is always less than 1, right? Which this is a unique conclusion. The interval of convergence, they weren't asking for it, but the interval of convergence is all reals. Okay, so the radius, I guess we could say it's infinity. It's not really a good technical way of saying that, but the radius is infinite. So that was kind of interesting result. You usually get interval of convergence that's restricted between certain numbers, but sometimes you don't. Okay, 15. So these are all power series. So we're going to do the ratio test. I want you to write down the name of the test that you're using. For power series, we always start with the ratio test. Right, limit as it goes to infinity, absolute values, you need that. You need absolute values, otherwise I'm taking off points. N plus 1 term. Divided by the nth term. Multiply by its reciprocal. Okay. And then we are going to simplify using rules of exponents. And so we could rewrite it limit. I haven't taken the limit yet. I'm going to put the n plus 1 over n. Those can't reduce. And then you have x plus 3 over 5. Now this is going to go to 1 when you take the limit. So we're going to have x plus 3 over 5 less than 1. So got options. You could say, all right, -1, x plus 3 over 5 to 1. Or you could multiply both sides by 5 before getting rid of it. And this is your radius right there. This is your center is the value that makes it 0. X equals -3. Or you could do this and try and figure it out after the fact. This is funny because it looks like the exact same answer we got on number 11. Did I accidentally just redo 11? Okay, I need to stop and check this. Okay, so I think I did the wrong problem for 11. On 11, I did 15. I'm redoing it right now. I'm pretty much done. So I'm going to redo. I'm going to go back and do 11 right now that I caught my mistake. So 11 was supposed to be n to 0, n equals 0 to infinity of x minus 2 to the n over 10 to the n. So ratio test. Ratio test, limit as n goes to infinity, the absolute value of x minus 2 to the n plus 1 over 10 to the n plus 1 times 10 to the n over x minus 2. Just reduce this. So we get limit as n goes to infinity of the absolute value of x minus 2 over 10, which is actually, the n's are actually all gone. So it's just the absolute value of x minus 2 over 10. Has to be less than 1. So at this point, you could say, all right, negative 1, x minus 2 over 10 to positive 1. Or you could just say, let's multiply through by 10. And this is the radius. And this is the center without finding the full-blown interval of convergence. Otherwise, you come over here and you could do this extra work, which we're going to have to do most of the time anyways. So it's not like a bad use of your time. You're getting better at it. But sometimes you don't have to do all that. So this is 20, right? Diameter. Radius is 10. So that's number 11. I messed up. Radius is 10. Okay. And then, I don't know, I haven't checked it, but I'm assuming that's right. Okay, now the next problems say to determine the convergence or divergence of the series, identify the test or tests you use. There may be more than one correct way to determine the convergence or divergence series. I'd recommend right now that you do every possible way that you know of, because you're going to want to get good at all of them. And sometimes one doesn't work and you have to do another one. So it's good to just be able to try a bunch of different approaches. So that's what I would challenge you to do. On a test, just do the one that works. And if you do one that doesn't work, then try one more. But on homework, I would try them all. It'll confirm your answers. So the first test that we should always try is the nth term test. Now, by the way, these are number series. That's why we're going to have a bunch of different tests for number series. Nth term test. Power series is pretty much the ratio test. And then we use these number series tests for the edges of the power series, which we kind of avoided just because we're doing radius. Nth term test says take the limit as n goes to infinity of the nth term. And if you do that, these are the dominant terms, and this exponential is going to beat this linear, and it's going to go to infinity, which isn't the thing that needs to happen to diverge. It needs to not go to 0. So I want you to say not equals 0 still, right? And so based off that, it diverges. You named the test, you showed the work for it. The only other test we know right now is the ratio test. We're gonna learn a bunch more. Sometimes they're inconclusive. Sometimes they're conclusive. One tells the answer, one doesn't. They're not going to conflict with each other. The most they're going to do is just one's not going to be conclusive. So the ratio test says take the limit as n goes to infinity, the absolute values of the n plus 1 term divided by the nth term multiplied by the reciprocal, because they usually involve fractions, so that's helpful. Now, rules of exponents say we're going to get a 2 here, and then these are going to go infinity over infinity, but they're going to be 1, so you're going to get 2. Now, is 2 less than 1? No, it diverges, no matter what. So this is different than the ratio test to find the interval of convergence of power series, because those ones you always have like a absolute value inequality solve afterwards. These ones you just get an answer, you get a number, and it's either less than 1 or it's not, or if it's equal to 1, it's inconclusive. Okay, 31. So let's try the nth term test. So both of those agreed with each other last time. Now this is going to go infinity over infinity. These are the dominant terms. You have a quadratic versus an exponential. Exponentials beat those. They get way bigger, and this is going to go to 0. Now, what that means is it means it's inconclusive. This does not mean it converges. It means it might converge, it might diverge. So this is inconclusive. You cannot say anything. You can show me that it passes test, but that's not enough. So we're going to go to the ratio test. Limit as n goes to infinity of the absolute values of n plus 1. You got to put parentheses here, squared minus 1 over 2 to the n plus 1 times the reciprocal divided by the previous term. Rules of exponents, you got a 2 here. These are going to blow up. And this plus 1 really doesn't make a big difference. So these are going to go to 1. Those are the dominant terms there. One's, if you plug infinity squared, infinity plus 1 squared, and they're pretty close. So what we get is we get 1/2, which is less than 1, which means it converges by the ratio test. All right. 32. -1/8 to the n. Now, I think this is actually a geometric series, right? This is the same thing as, by the way, it's not alternating, it's just every term is negative. So if you're thinking of this as a geometric series, which we could call it a geometric series test, I'll actually write that down as an option. Nth term test, limit as n goes to infinity of -1/8 to the n goes to 0, which is good. Not enough, though. So then the ratio test, limit as n goes to infinity of the absolute values of -1/8 to the n plus 1 times the reciprocal. Rules of exponents, we're going to get 1/8, which is less than 1, which means it converges by the ratio test. Now, how about geometric series test? Because we've been using that one, and that's a possibility. Geometric series. This is geometric series with an r value that's equal to 1/8, not negative. Negative is not part of the r, which is 1/8, which is less than 1, which means it converges. So that's a possible test on our list. If it's a geometric series, you can call it a geometric series test and talk about the r value. By the way, the ratio test is giving you the r value. That's what you're getting. So, yeah, if you wanted to, you could rewrite this in a way that looks more like a geometric series. There's the R. Same thing. Okay, so that's 32, 33. Nth term test. Limit as n goes to infinity. In the future, probably just do it in your head, unless it gives you bad news, then you want to write it down. So these are the dominant terms that go infinity over infinity. This one dominates this one because they're both exponentials, but this one has a bigger base, so it's going to go to 0. But that's inconclusive. Inconclusive. All right, this last one. Inconclusive. That doesn't tell you the answer. If that's all you write and you say it converges because of that, you're not getting credit. Okay, let's try the ratio test. Limit as n goes to infinity, absolute values of 2 to the n plus 1 over 3 to the n plus 1 times 3 to the n plus 1 over 2 to the n. Rules of exponents could work on those ones. So, I mean, at some point I'm starting to get lazier and just do more work in there. But if I want to be a little slower, I could say, okay, let's do this. 3 to the n plus 1, or 3 to the n plus 1 plus 1. You can't reduce that times 2. But you can get infinity over infinity. These are the dominant terms. They're roughly, well, these are the dominant terms. So you're ending up with a 3 because this one has a higher power. So if we get rid of these because they're negligible, we're still going to get a 1/3. So we're going to get 2/3, which is less than 1. Okay, 2/3. Not 1, not 2, 2/3, because that totally makes a difference. So this one converges based off the ratio test. This is not a geometric series. Okay. So nth term test. Limit as n goes to infinity of n squared e to the negative n, which is also, by the way, the same thing as limit as n goes to infinity of n squared over e to the n. So infinity over infinity, but the bottom is an exponential, which is going to beat the quadratic on top. So it's going to 0, but that is inconclusive. So then we're going to try the ratio test. Write the name down, show the work, limit, n goes to infinity, absolute values. So I think I'm going to go with this version. That's going to be easier to do work with. So it's going to be n plus 1 squared over e to the n plus 1 times e to the n over n squared. Rules of exponents. Get an e. These guys, I mean, you could combine them n plus 1 over n squared. But that's going to go to 1. Infinity over infinity, dominant terms are the same size. Square is going to be 1 squared is 1. So you're going to get 1 over e, which is less than 1. Right? E is like 2.7 or whatever. So it converges. Now, I know I'm doing nth term test every time. It's not really helping me, but it helped us on 30, and it'll show up. I think the 1 out of 10 times it helps you in general is worth it, because otherwise you're going to start going and trying to do more complicated tests that might not be conclusive, and you'll have to end up coming back to it. And it's the simplest test. Like I said, you can just do it in your head real quick. Nth term test. Just, if I take as n goes to infinity, what happens to that? Does it go to 0? If not, that's a problem. So this is going to be infinity over infinity, but we have a 10th degree polynomial on top and an exponential on the bottom, which is going to win. But that's inconclusive. All right. So ratio test. Limit as n goes to infinity of the absolute value of n plus 1 to the 10th power over 10 to the n plus 1 times 10 to the n over n to the 10th. And rules of exponents, we could simplify that down a little bit. And we could put the n plus 1 over n inside the same power of 10. So this looks a lot like last one. Now this is just going to end up going to 1. We're going to get 1/10, which is less than 1, which means it converges by the ratio test. Okay, 37. Has a bunch of factorials in it. You guys can do this. You can do it. All right, so nth term test. Limit as n goes to infinity of n plus 3 factorial over 3 factorial, n factorial, 3 to the n. I think we could simplify this a little bit, which would probably help. N plus 3 factorial is n plus 3 times n plus 2 times n plus 1 times n factorial, which would cancel with that one on the bottom. And then we have 3 factorial and 3 to the n. So we can get infinity over infinity, but this is essentially a cubic on top, and this is an exponential on the bottom, so it's going to go to 0. And so it's inconclusive. So I guess we could have, I don't know. I think that was the best idea. Simplify a little bit. Okay, ratio test. We take the limit as n goes to infinity of absolute values. This is going to be n plus 4 factorial over 3 factorial, n plus 1 in parentheses factorial, 3 to the n plus 1. This is messy. Times, divided by the previous term, or times its reciprocal. Now, we have a lot of factorials in here that we can reduce. These 3 factorials just go away. The 3 to the n, 3 to the n plus 1, you get 3. Now, what I would do is I'd do these together. I'd say, oh, well, this is n plus 4 times n plus 3 factorial, which cancel with that. And this n plus 1 is n plus 1 times n factorial, so that would cancel with that. So what I have now, just with simplification, is I have an n plus 4 on the top, no more factorial. I have an n plus 1 on the bottom, and a 3. Now, this is going to go to 1, and you're going to get 1/3, which is less than 1, which means it converges by the ratio test. Okay? So you got to be good at all this simplification stuff. I mean, that's going to make a huge difference. And you got to make sure you don't make mistakes with it. Okay, 40. We try the nth term test. Let's see. And I would rewrite it and say, okay, limit as n goes to infinity of n factorial over e to the n, which I'm probably going to do that for the ratio test too. Now, this is going to go infinity over infinity, right? But which term is dominating, the exponential or the factorial? The factorial dominates, and this goes to infinity, which is not equal to 0, which means it diverges. And in this case, this problem, you can be done. Ratio test is going to be much more work and mess for hopefully the same conclusion. Hopefully not inconclusive. So n plus 1 factorial over e to the n plus 1 times e to the n over n factorial. Rules of exponents, factorials, get n plus 1 over e, which if you take the limit as it goes to infinity, which is not less than 1, which diverges by the ratio test. So both of them agreed. They're not going to disagree, but one could be inconclusive. But this was the way faster way to do it. And it's, like I said, in the future, you're going to just do that in your head real quick. And then if you're like, oh, that's going to make a difference, then you write it down. But you should always start with at least thinking about the nth term test and evaluate it at least in your head. Okay, 43, last one. Nth term test. Now, infinity over infinity, the one on the bottom is bigger because there's going to be a bunch of extra terms here to eventually get down to n factorial, and then they would cancel, but there's going to be a bunch of n's in the bottom, and it's going to go to 0, which is inconclusive. Okay, so now we have to do the ratio test. Limit as n goes to infinity, absolute value, n plus 1 factorial over 2n plus. Now you plug in n plus 1 in there, you get 2n plus 2 plus 1 that's already there, 2n plus 3 factorial. Don't mess that up. Now I want to use rules of factorials. 2n plus 3 factorial is 2n plus 3, 2n plus 2, 2n plus 1 factorial. And n plus 1 factorial is n plus 1 times n factorial. So we're left with this and this. So I'm going to rewrite that. Just make it super clear. We have an n plus 1 on the top, and we have a 2n plus 3, and a 2n plus 2 on the bottom. And I haven't done any limits yet. I just simplified. Okay, now as n goes to infinity, it's going to be infinity over infinity, but the bottom is going bigger than the top because it's quadratic. So it's going to go to 0 no matter what, right? It's going to go to 0, which is less than 1, which means it converges by the ratio test. The nth term test was inconclusive. So, this term right here, the dominant term on the bottom is going to be the 4n squared compared to the n to the first pair there on the top. So the bottom's dominating. Okay, that's it. Be good at this stuff. We're going to be adding more to our list soon, more tests, and you got to be good at all of them and know when to use them.